Good evening. Welcome to my channel. Biro lang. Okay. So tonight I will discuss about the effect of RS and RL. So by the way, what is RS and what is RL? So yung RL is the load resistance. So RL is the load resistance and the RS is the from the subscript itself we have the source resistance. Okay? So now, what we are actually solving last time is di ba sinosolve natin yung AV, yung voltage gain ng mga bawat configurations. Now, to be specific guys, AV lang kasi yun di ba? Ngayon, what we are actually solving is the AV or the voltage gain in no load condition. So, maglagay na lang tayo ng subscript. So, we have this one, AVNL stands for no load. Okay, so bali ganito yun, di ba? We have the VO and we have the VI. And then, at this part, di ba, doon natin kinukuha yung ZI. And from this side naman, doon natin kinukuha si ZO or the output impedance. Okay? So, in no load condition, ang kinukuha natin is the AVNL. Okay? Ngayon naman, kapag may nilagay na tayong RL, kay RL, since naglagay na tayo ng load resistance dyan, okay, yung VO natin is doon na natin kukunin right after nung load resistance natin. So, kapag kinuha natin yung overall gain na to with the presence of the RL, so kinukuha natin yung AVL. Okay, meaning may kasama ng RL. Okay? And then, next one is in the presence of RS naman. Okay? So, kapag kinuha naman natin ang overall gain na to, okay? So, hindi na dito yung magiging reference natin, kundi doon yung input voltage which is the Vs. Okay, stands for source. Okay, source and then source is the source resistance which is in series doon sa base natin. Of course, meron tayong coupling capacitor na dito. Okay? So, kapag kinuha natin yung overall gain nito, so we have AVS. Okay? So, kailangan guys, ang AVS is present na si RL and then si RS. Okay? So, in summary, so ang AVNL is the no load. Okay? Walang RS, no RS, no RL. Okay? Kapag sinabing AVL naman, okay, meron ng with RL. And then kapag sinabing AVS, okay, ito naman is with RS and of course with RL. Okay? Now, there are some things you have to remember. Okay? So, the loaded voltage gain of an amplifier is always less than the no load gain. Okay? The gain obtained with a source resistance in place will always be less than that obtained under loaded or unloaded conditions. So, ito yung summary niya. For all configurations, guys, okay? Si AV no load, okay, is always larger than AVL and AVS. Take note, guys. Take note that ito dapat yung smallest sa kanila, okay? This is the smallest gain, yung AVS, okay? And then, si AVNL naman, siya yung highest. So, of course, in between yung AVL, yung may loaded resistance na. Okay? And in addition, for a particular design, the larger the level of RL, the greater the level of AC gain. Okay? So, paano ba to? Take note that, di ba ang AV natin, okay, since may RL yan, so AVL, di ba? Usually, di ba, VO divided by VI, di ba? Ito yung general formula for gain. Ngayon, since may RL tayo, say we have the IO RL divided by II. Tapos, since wala pa naman si RS dyan, so ZI muna tayo, okay? So, sinabi dito kapag the larger the level of RL, okay, the greater the level of AC gain, di ba? Kasi si gain is directly proportional doon sa RL. Okay, so kapag tumaas siya, of course, tataas din yung AV natin. Okay? Ganun din dito sa pangalawa. For a particular amplifier, the smaller the internal resistance of the signal source, okay, the greater the overall gain. Okay? So, dito naman, so since internal resistance or the RS, okay, so let's say that is the RS, okay? So, kapag mababa yung RS natin, okay, since nasa uh, input side siya, say this is the RS, okay? So, habang bumababa yan, okay, of course, tumataas yung AV, AVS natin, okay? They are inversely proportional, okay? So, the smaller the internal resistance, the greater the overall gain, okay? And then for any network that have a coupling capacitors, the source and the load resistance do not affect the DC biasing level. So when we say the DC biasing levels, so ito kinocompute natin yung VB, yung VE, and then VCE, mga ganyan. Bakit? Okay? Yun ang importance nitong coupling capacitors. Okay? Take note that tingnan natin yung mga, eto, di ba? We have two coupling capacitors here. Okay? So, at DC, di ba? Cut yan di ba? So, meaning walang connection ito doon uh, sa circuit natin. Ganun din sa output, di ba? Since cut yan, so walang effect itong RL doon sa circuit natin. So, we can apply KVL here para to solve for the necessary unknowns like IE, IB, VC, VCE, mga ganyan. Okay? So, eto. So, ito yung complete na di ba? Ito yung complete na circuit natin with the presence of RS and RL. Ngayon, if you still remember, kapag ito, i-drawing natin siya, okay? I-transfer natin siya or i-draw natin siya, i-draw natin yung AC equivalent circuit nito. Take note that yung RL is in parallel, okay? Para yung VO natin, okay, kakabit sa collector natin, then diretso ground. And then yung RS natin, okay? 'Di ba dito? Ito pa rin yung magiging ZI natin. Okay? Ito pa rin yung magiging VI natin, okay? Ito yung magiging input pa rin natin, VI. Okay? So, of course, for the VO, medyo magbabago. Diyan pa rin yung diyan na yung VO natin, pero yung ZO natin or the output impedance, okay? So, diyan natin kukunin pa rin. Okay? Before nung load resistance. Okay? Take note, yung connection niya, naka-series sa RS, then naka-parallel si RL. So that, yung equivalent circuit niya is ito. Diba? So, in series si RS, and then naka-parallel si RL. Ito yung sinasabi kong VZO. Diba? Right before nung RL natin. And then si ZI doon pa rin sa base ng ating BJT. And then since wala tayong emitter resistance, so diretsong ground. Diretsong ground to. Okay, so familiar naman kayo sa circuit na to. Okay, this is a common emitter configuration. Kaya nga lang, walang emitter resistance. Okay? So, knowing this one, guys, before we go to the two-port system approach, tingnan muna natin kung paano ba natin kukunin yung AV. Paano natin kukunin yung AVNL? And then, paano natin kukunin yung AVL? And then, last one is paano natin kukunin yung AVS. Okay? So, doon muna tayo. So, ito rin yung natin. Yung kanina. Okay? AVS with RL and RS. So, ito yung circuit. So, ito pa rin yung things to remember. So, pareho lang doon. Okay. Now, take note that without RL, di ba? Without RL and without RS. So, tanggalin nyo muna. Tanggalin nyo muna yan. Di ba ang AV natin? Yung AV na sinosolve natin dito is that, di ba ang AV natin is, since common emitter yan, di ba? Negative RC divided by RE. Di ba ganyan? Ngayon, kapag meron tayong load resistance na doon, so kukunin na natin yung AVL niya. Take note that yung RL natin is in parallel with RC. Di ba? Itong dalawa is in parallel. Okay? So, to compute the AVL, so si RC, di ba, in parallel with RL divided by RE. So, madali na lang i-memorize. Di ba? Kasi alam nyo na dati to. Okay? Idagdag nyo lang yung RL na nakaparallel doon sa RC. And how about yung AVS? Okay? So, yung AVS natin is ito. Okay? Yung ZI na tinutukoy dito, yung ZI na tinutukoy dyan is yung sinosolve natin na ZI dito. Okay? Yung ZI dyan. Okay? So, RB in parallel with beta RE. Okay? So, ZI. And then, since nakaseries si RS doon, di ba? So, parang nag-voltage divider ka lang. Di ba? Pero in terms of gain naman to. So, yung AVS natin is ZI. Okay? So, parang parang ganito yung itsura. And of course, ground yan. Okay? So, ito si RS. Ito si ZI. Okay? So, parang nag-ano ka lang, di ba? Kukompute ka lang ng voltage doon sa ZI natin, di ba? So, yung AVS natin is ZI divided by ZI plus RS times AVL. Okay? So, parang domino effect. Okay? So, to compute AVL, okay, you need AVNL, di ba? And to compute for AVS, you need AVL. Okay? So, kailangan mo munang i-compute yung AVNL to solve for AVL. Okay? So, that is a case-to-case basis. Okay? But this one, ito kasi is diretso na, di ba? To solve for AVL, So, kunin mo lang yung parallel combination ni RC at saka RL divided by RE. Okay, just take note of this one. Parang voltage divider ka lang. Okay? So, example tayo. Okay. So, hindi ko sinabi kung anong circuit to. Basta 5.1 daw yan. Okay? So, hanapin nyo na lang. And then, i-write ko na lang dito. Okay. So, yung figure dun sa 5.1 na tinutukoy, okay? So, is ito. So, yung complete na lang. Ito yung RS. Then, ito yung coupling capacitors. Then, wala muna tayong emitter resistance. Okay? And then, yeah. So, we have 12 volts. Then, meron tayong 3 kilo ohms. Then, meron tayong 470 kilo ohms. And then, meron, okay. So, ang beta for this one is, mamaya, ino ko muna to. So, we have Vs. Okay? And then, beta for this one is 100. Okay? Assume, okay, ito na naman. So, lahat ng kinocompute natin is assume that RO is infinite. Okay? And then, ang sinabi doon is ito. Using the parameter values of a fixed bias configuration, so yung circuit nga na dinrawing ko kanina, okay, meron tayong applied load of 4.7 kilo. Okay? Applied load na 4.7 kilo. So again, meron tayong coupling capacitor. Ayan, and then we have VO here. Meron tayong meron tayong RL na 4.7 kilo. And the source resistance of, ayan, 0.3 kilo ohms. Or, ito ay equal to 300 ohms. Diba? So, gawin ko na lang na 300. 300 ohms. Okay. So, yung AC equivalent nito guys, diba? So, yung AC equivalent niya is ganito. So, meron tayong RS. Okay. And then, meron tayong 470 kilo grounded. Then, we have VS. Okay. Ito C. 300. Ito naman C. 470 kilo. Okay. Then, meron tayong beta RE dito. Okay. Tayong beta RE. And then, ito yung IB natin. Diba? IB. Then, meron tayong ito. Ayan. And then, meron tayong, of course, ito yung VO natin. Okay, VO. Then, meron tayong 3K. Then, we have the RL, which is the 4.7 kilo ohms. Okay? So, kung titignan natin, let's compare the circuit. Okay. Ito. Okay, wala nga lang RO muna. Okay? So, okay, what are the things we have to obtain with these given values? So, pareho din kung ano yung sinosolve natin nung dati, solve pa rin ulit natin. Okay? Since at DC, cut mga to, so we can apply KVL. Okay? Can apply KVL to solve for IE and then for RE. Maliit. So, you have negative 12 volts plus 470K and then IB, okay, plus 0.7 equals 0. So to solve for IB, so you can actually solve it, shift solve na lang, di ba? So IB natin is 24.04 microampere. And for IE, by using the exact value, so we have 101, di ba? 101 kasi beta plus 1 times IB. And then ang IE natin is equal to 2.43 milliamperes. And to solve for RE, lagi natin ginagamit, 26 millivolts divided by IE. So, makukuha natin na RE is 10.7 ohms. Okay? 10.7 ohms. So, that is our RE. Ngayon, what are the things that we need? Okay? So, to solve for, ano ba yung tanong daan? Okay? Determine the following. Okay. We have to solve for AVL. Okay? AVS, of course, ZI, and ZO. So, ito yung una natin makukuha, di ba? Yung ZI and ZO. So, to solve for ZI, di ba ang ZI is ito? Ito yung VS natin. Pero andito pa rin yung VI natin. Okay? So, that is our VI, positive and negative. And of course, yung ZI natin is seen looking at this side. And then, si ZO natin is ito si ZO. Okay. So, yung ZI natin is 470K in parallel with beta RE. So, yung ZI natin is 470 kilo in parallel with 100 times 10.7. So, solving for ZI, okay, so calculator, so we get 1.07 kilo ohms. Okay, that is our ZI. And for ZO, okay, of course, ang ZO natin is 3K, okay, which is equal to RC. RC or equal to 3 kilo ohms. So that is our Z sub O. Now, to solve for AVL, okay, to solve for AVL, diba? Diba kapag wala yung RL natin, ang AV natin for the AV no load is equal to negative RC over RE. Ngayon, since meron tayong load na nakaparallel doon sa RC, so ang AV natin is negative RC in parallel with RL divided by RE. Okay? So, ang AVL natin is equal to what? So, paki-solve na lang din, ha? We have 4.7 kilo in parallel with 3 kilo over RE is 10.7. Okay? So, solving it, so ang AVL natin is equal to negative 171.14. So, that is our AVL. Okay? And then, for AVS naman, diba ang AVS parang nag-voltage divider ka lang, diba? So, we have ZI, okay? ZI plus RS times AVL. Okay? So, equal to, ang ZI natin is, ito ZI natin is 1.07K. So, 1.07 kilo divided by 1.07 kilo plus 300 times yung AVL na na-compute natin. So, we have negative 171.14. Okay? So that, ang AVS natin is equal to negative 133.66. Okay? Now, i-compute lang din natin si AV no load. Okay? To solve for AV no load, diba, RC over RE. So, negative 3K divided by RE is 10.7. So, ang AV no load natin is equal to negative 280.37. Ngayon, i-compare natin yung things to remember kanina. Diba? That is, si AV no load is greater than AVL, which is, si AVL is greater than AVS. So, huwag nyo munang pansinin yung sign. Okay? Yung sign naman is hindi yung parang sa Cartesian na habang lumalaki is maliit yung value. Okay? Ito yung sign na to guys is just the phase reversal. Okay? Phase inversion lang yan. Okay? Ang importante dito is yung mga magnitude natin. Okay? So, doon na tayo using itong formula natin, okay? And then, meron din tayong two-port system. So, ano natin dito? Okay, so kung i-compare nyo dyan, yung mga sagot natin, may discrepancy. Kasi nag-ground ang ginawa natin. Okay? Nag-ground tayo. Pero medyo malapit lang naman. Okay? So, for the voltage divider configuration naman, the important thing here is kaya pinapasulat ko sa inyo yung mga circuit niya para ito is alam ninyo kung paano i-drawing yung AC equivalent nito. And then, idagdag nyo na lang yung mga RL. Okay? Ang di naman magbabago yung RL natin is always in parallel doon sa ZO natin. Okay? And then si RS naman is always in series doon sa ZI natin. Okay? And then, alam nyo naman na kung ano yung mga formulas involved kapag ganito yung ano natin. Diba? Dagdag nyo na lang yung RS and RL. Okay? Tignan nyo dito. Yung AVL natin, ganoon pa rin, di ba? Si RC is nakaparallel pa rin kay RL. Okay? And then, ito naman. For the emitter-follower configuration, di ba, dun sa emitter-follower is, nandun sa emitter yung output natin. Di ba ito? Kasi parang common collector na siya. Di ba? So, yung AV, yung AV natin, okay? Di ba ang AV natin without the load is ito, RE over RE plus RE. Ngayon, since may RL na nakaparallel doon sa RE natin, okay? Kunin nyo lang din. Parallel nyo lang dito. Okay? Since may dalawang RE na included dito, so both should be equal. Okay? Ito, nakaparallel din dapat si RL. Ito rin nakaparallel din si RL. Okay? Ganun lang. I-parallel combination nyo muna. Okay? Now, for the current gain is ito. So, AIL natin is negative AVL ZI over RL. Okay? So, take note nyo lang yung mga formulas na yan. So, AIL. So, dun tayo sa may two-port system approach. Okay? So, yung sa two-port system approach natin, okay. So, ganito yung itsura. Okay? So, yung buong circuit natin is dinescribe as isang block diagram na lang. So, of course, without load. Okay? So, ang AV nito is AV no load. Yung usual na sinasolve natin last time. Okay? AV no load. Okay. So, yung internal circuitry niya naman is ito. Okay? So, RI, okay? Ito yung ano. Ano tong RI na to? Okay? Bago hindi po siya bago. Yung RI natin is yung kinukuha nating ZI. Okay? Si RI is equal to ZI. And then si RO naman, siya si ZO na kinocompute natin. Okay? Ito. ZI equals RI. ZO equals RO. And then, considering this figure guys, di ba since wala tayong load dito, load resistance, di ba? If we apply KVL at this loop, di ba? Since open yan, say that is current I. Okay, current I yung dumadaloy dito. Since open yan, ang current natin ay 0. Okay? So, we have negative since voltage yan. Okay? Negative, papasok tayo sa negative. So, negative yan. Negative AV NL VI, di ba? Plus, okay, plus RO times yung I na current, di ba? Then, plus VO. Okay? Since ang current natin ay 0 kasi open siya, di ba? And then, wala pa tayong RL na kinabit. Di ba? Ito ay 0. That's why, di ba? Equal to 0 yan. Di ba? That's why si VO, okay? Si VO is equal to AV NL times VI. So, kaya nakuha to. Okay? And then, yung AVNL natin, kung i-rewrite natin to, ang AVNL is just equal to VO over VI. Okay? So, ito. That is without RL muna. Okay? You have to take note the circuit. Okay? Yung itsura ng RI, okay? Then, tsaka itsura ng RO. Okay? So, nakaseries naman si RO. Ito naman is connected doon sa ground, si Zi. Okay? Ngayon, if we have RL na na-connected, okay? So, ito guys is parang kumukuha ka lang din ulit ng ano, parang nag-voltage divider ka lang din ulit. Okay? So, ano voltage dito? Diba parang ganun? Ano yung voltage dito? Anong voltage VO dito? Okay? Pero in terms of gain naman tayo, di ba? So, yung AVL natin, di ba? RL. Okay? Since dito natin kukunin yung output natin at this terminal. Okay? So, RL divided by RL plus RO times AVNL. Okay? AVNL. So, lahat ng formulas na to, itatry natin and then i-compare natin sa mga values obtained kanina. Okay? And then, paano kapag may RS na? Okay, take note, wala pang connected na RL dito. Okay? So, kailangan, di ba ang AVS is may connected dapat na RL. Pero paano kung walang RL pa na connected? Okay, so itong formula ang gagamitin natin. Okay? Ri divided by Ri plus Rs times AV no load. Okay? No load. Kasi walang connected na load dito eh. Diba? So, Ri plus, parang voltage divider lang din ulit. Okay? Ri divided by Ri plus Rs times AVNL. Kasi walang load. Okay? Inulit ko lang. Ngayon, paano kung may RL na dyan? Paano kung may RL na dyan? Okay? So, ito yan. So, ang AVS natin is dagdagan lang dito, di ba? Idagdag lang dito. So, Ri divided by Ri plus Rs times RL over RL plus RO plus AV and L. But take note that ito, okay, ito, di ba ito lang din siya? So, meaning, ito is AVL. Okay? So, to solve for AVS, you need AVL. Okay? And then, for solving AVL, you need AVNL. Okay? Let's use these formulas. Okay? Para i-compare yung mga values na to kung tama lang ba. Okay? Using two-port system approach. Okay? So, yung drawing kanina, okay, is ganito. Meron tayong Ri which is equal to Zi. Tama. And then, meron tayong ito. Ayan, positive, negative. Okay, meron tayong Ro. Okay? Then, this is Vo. Then, of course, ito ay ground. Okay? Ito yung RL, tapos ito yung RS. Then, meron tayong Vs. Positive, negative. So, ito ay yung Ri or the Zi. Di ba? Pero ano yung Zi natin na sinolve kanina? Ang Zi is 1.07 kilo. Di ba? And then, Zo or Ro. Di ba ito yung Ro natin eh. And then, ito lang din yung ating Ri. So, 1.07 at saka 3 kilo. So, meron tayong 3 kilo. And then, meron tayong 1.07 kilo. Then, ang Rs natin ay 300 ohms. And meron tayong RL na 4.7 kilo. Okay. Now, and AVNL VI. Okay? Ayan. So, ito yung AVNL VI natin. AVNL. Okay. Okay. Ngayon, since known naman na to, which is itong 280.37, diba? To solve for AVL, diba parang nag-voltage divider lang tayo. Diba sabi ko? Now, since this is a voltage, kasi positive negative, diba? So, what is VO? Diba? So, ang VO natin is equal to, saan natin kinukuha? Dito sa 4.7 kilo, diba? 4.7 kilo, okay, divided by 4.7 kilo plus 3K times, di ba yung voltage na to is the AV and LVI, di ba? So, AV and LVI. But take note that yung AV natin, okay, is equal to VO over VI, di ba? So, itong VI natin, ilipat natin sa denominator, di ba? Divide natin both sides by VI, okay? So, ito magka-cancel lang, di ba? If we divide both sides by VI, okay? So, pinakita ko lang para mas mag-gets na rin ng iba. Okay, di ba ito? Cancel, cancel. Okay, so this is AV. Okay? But since may load na included, so lagyan na lang natin subscript. Okay, AVL. Okay? So therefore, yung AVL natin, okay? So yung AVL is equal to 4.7 kilo divided by 4.7 kilo plus 3K times, anong AVNL natin? Compute doon, di ba? Negative 280.37. Now, solving the AVL using this formula, okay, ang makukuha natin na value ay negative 171.13, which is equal doon sa unang computation natin. Okay, so may discrepancy lang sa decimal place niya kasi syempre dun sa rounding na ginawa natin. Okay, so ang AVL natin using this parallel combination naman, okay, ito. So they are the same. Okay, 171.14, 171.13. Ngayon naman, to solve for AVS, okay, so ang AVS natin, di ba parang nag-ano ka lang din dito, di ba? Voltage divider ka lang. Di ba? So, since dito mo kukunin ang voltage natin, kumbaga, di ba? So, ang AVS is 1.07 kilo. Okay? Kasi ang formula is ito. So, RI. Okay? RI or ZI. Di ba? Ito is ZI din. Okay? Knowing that this one is already our AVL. Okay? Na-compute na kanina. Diba? So, ZI, which is 1.07K, divided by 1.07 kilo plus 300 times AVL, which is ito. Okay? Then, substituting the value and then computing it. So, ang AVS natin ang lalabas ay so we have 100 negative 100 133.66. Okay, is it the same doon sa nauna? 133.66. Okay, ito yung nauna using the parallel combination. Ito naman using two-port system. Okay? So, kahit anong formula ang gagamitin ninyo guys, pareho lang. Then, it's up to you kung ano yung mas prefer ninyo. Okay? It's either itong two-port system or yung i-parallel yun na lang. Okay? And then, i-series yun na lang. Okay? So, it's up to you guys. Okay? Wala namang mali doon. Siguro yung magkakamali lang kayo kapag yung pag-input nyo sa calculator. Okay? So, ano bang next? Two-port system. Okay. So, ito naman. Okay? Determine the AVL, okay? And compare it to the no-load value with RL. Okay? So, let's just compute siguro ito. Compute natin. Compute. So, burahin ko na to ha. Anyway, recorded naman. Pwede niyong ibalik na lang. Okay? Ayan. Pagkasay lang natin. Masyado pang ano. Okay. 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 So, since given na yung AV NL natin, okay? And then, the ZI and ZO is given also, okay? So, determine AVL and compare it to the no load with RL, okay? So, ito muna to yung RL natin. What if yung RL natin ay 1.2 kilo? Okay? So, ang AVL natin, AVL ay RL, di ba? RL over RL plus ZO, okay? Times AVNL equal to, anong RL natin? If RL is 1.2 daw, 1.2 kilo over 1.2 kilo plus, so RO or DZO is 2 kilo times negative 480. So, ang AVL natin is equal to, compute natin, 1.2K times negative 480. So, 1.2K plus 2K. Okay. So, AVL natin ay negative 180. So, sobrang baba ng AVL natin. Okay? And for letter B, okay now, what if AVL ulit ang kinukuha dito? Okay? Repeat part A daw with RL naman. What if RL is 5.6? So, papalitan nyo lang ng 5.6 yung RL natin. Okay? So, ang AVL natin is 5.6 kilo divided by 5.6 kilo plus ZO is 2K times negative 480. So computing that one, 5.6 and so we have negative 353.68. Okay. So na-meet natin yung reminder kanina that habang tumataas yung load resistance natin, okay? Siyempre tumataas din yung gain natin as compare with letter A or yung nauna, di ba? Ang 1.2 kasi mas maliit kaysa 5.6 kaya maliit din yung AV niya, AVL. Okay? And then for letter C, determine AVS with RL equals 1.2. Okay. Since 1.2K ang RL natin, so ito yung kailangan natin na AVL. Okay? So to solve for AVS, okay, ang AVS ay ZI divided by ZI plus RS times AVL. Okay? Pero take note, ang sinabi is 1.2 kilo ohms. Okay? So ito yung kailangan natin na AVL. So ang ZI natin is ito, 4K. 4K divided by 4 kilo plus, okay, ang 0.2 kilo ohms ay 200 ohms times negative 180. So ang AVS natin is equal to 4K over 4K plus 200 times negative 180. Okay, so we have negative 171.43. Okay, so yan yung ABS natin. Okay? So find the current gain naman, AI, with RL equals 5.6. Okay? So ang kukunin naman natin ngayon is yung AI daw. So to solve for AI with RL equals 5.6. Ayan. Ano ba tinutukoy dito? Is it the AIL or the AIS? Okay? I-solve na lang din natin para walang masabi since hindi naman sinabi kung AIL ba or AIS. Okay? So for AIL with RL is 5.6. So ang AIL natin, ayan. AIL with load, so negative AVL, okay, times RI over RL. So anong AVL natin dito? Kapag 5.6 yung RL, kapag 5.6 ang RL natin is negative 353.66. Okay? So negative so I don't know if kailangan bang i-retain yung sign niya or what. Okay? So, for the sake of discussion na lang, i-consider na lang natin. Okay? So, negative AVL. So, since negative to, and then negative yung AVL natin, so magiging positive. Okay? Positive 353.68 times anong RI natin or DZI. So, 4K times RL natin ay 5.6 kilo. Okay? So, ang AIL natin ay yan. AIL. So, 353.68 times 4K divided by 5.6K. So, we have 252.63. Ayan yung AIL natin. And then, for AIS, okay, for the AIS, so we have AVS naman. Okay? So, what is AVS kapag ang RL ay 5.6 daw? So, balik tayo dito. Okay? Balik tayo dito. So, ang AVS natin, kasi kailangan natin ng AVS dito eh. Okay? So, ang AVS is equal to, ano yung ZI? Ang ZI natin, 4K divided by 4K plus 200 times AVS to, hindi AVO. Pangit ng sulat ko kasi eh. AVS. Anong AVL natin? With 5.6. So we have negative 353.68. Negative 353.68. So, ang AVS natin ay 4K times negative 353.68 4K plus 200. 336 negative 336.84. So, ito yung ABS natin if yung RL ay 5.6. Okay? And for AIS, we have negative. So, ito ba? Negative AVS. So, pero negative na dati yun. So, positive. Diba? 336.84 times RS ay 200 plus RI, which is C4K divided by RL natin. What is the RL? RL is 5.6 K. Okay? So we have 336.84 times 200 plus 4K divided by 5.6K. Here we have 252.63. So 252.63. Okay? So as you can see, yung AIL natin, okay, is equal to AIS or equal to AI. Okay? So kahit isa lang gamitin ninyo, okay lang siguro kasi the same lang naman. Okay? So what's next with this one? Ayan. So yung mga examples natin guys, solve nyo na lang. Okay? So ito is parang kamukha lang naman nun, di ba? Just solve for the AVL since wala namang RS na binigay. And for this one, okay, may included na RE. Okay? So madali lang naman yan. May examples naman tayo ng ganyan. Okay? Idagdag nyo lang yung RS and the RL. Then, please try this one, ha? Okay, for the cascaded system naman, okay. So, that will be my next video. Okay? So, for the meantime, isolve nyo muna yung mga examples na since given naman na sa inyo yung PDF file nito. Okay? So, if there are questions or clarifications dun sa pag-solve natin, okay, just PM or message doon sa GC natin. Okay? Basta yun lang importante guys ha. Huwag niyong kakalimutan yung AC equivalent circuit natin and yung formulas na included sa mga circuits na yan. Okay? Kasi doon tayo magbe-base parate. Okay? So, 11:58 PM na. Okay? So, thank you for your time and thank you for watching to my channel. Okay? Good night, everyone.